Hello and welcome to another lesson in PIC microcontroller software implementation and hardware construction. Today we're going to be looking at EEPROM and using the I2C protocol. So what we're going to be looking at today is we're going to be looking at the 24LC64, which is a serial EEPROM memory. It's a 64K. It's made by obviously Microchip, and what we're going to be doing is we're going to look at how to use the I2C protocol and with CCSC compiler to talk to this thing. Just a quick overview. This is the data sheet. You can get it from Microchip's website. Basically, here's the pinout that we're going to be using. I think I used the SOIC is what I use package. So you just got your VCC, your VSS, and then your clock and your data. And that's basically basically all you're going to need for this simple demonstration. What we're going to do, you've got all your features that it has. You also have all your electrical characteristics. There's even timing diagrams, I believe, like if you go down through here. That's another thing that is great about the CCSC compiler, which we'll see in a little bit in the coding section of this, will be they've pretty much already written all this stuff down for you, all the handshaking and acknowledgments and everything that goes between the program and everything for the I2C bus protocol, so basically to interface with the protocol. This is basically all taken care of for you for the CCSC compiler. I have not looked into I2C with high-tech C programming language, or compiler, I'm sorry, yet. I'm looking at high-tech C. I'm going to try to, I've had a couple people ask me about high-tech C and want to know how to do it with high-tech C since it comes free with MPLabs IDE, and I'm actually in the process of working with high-tech C for some other projects and things. So as I become more familiar with that compiler, I'll try to do some videos that have that compiler's commands and things in it, so that way you guys can get kind of a couple different flavors of compilers. But anyway, let's go ahead and keep going with this. Let's take a look at the hardware, shall we? What we're going to do is we've got our go ahead and get our plug. We've got a barrel connector over here now, and we've got our 24 volt in, our 5 volt out, our two decoupling capacitors. We've got our 10K resistor for minimum clear, pulling that up to a high. And then what we got is we've got our EEPROM, and we've got our VCC and our ground, and then basically all we have is our serial data and our clock going up into our microcontroller. Now, I think in one of the data sheets, I think it might be the application notes that mentions this, but you've got your 3.9K ohm resistors. I think it's, it could be anywhere, I think from 3.9 to 4.7, somewhere around in there, K, that you want to have as a pull-up resistor on this, so that way you get hard zeros and ones. You don't get any floating values that you could have if you just connect these directly. And I know from my experience that it will not work unless you have these in there. And if you want to know what application notes, see, I think I might be able to pull up something. If we go to microchip.com, you can look at the 24LC64, I believe is what it is. Yeah, here we go. And so you click on that. If you come down here to the application notes section, see, here's where you can get the data sheet. If you come to the application notes section, and it's in one of these, I can't remember which one it is, might be this one, but in one of these application notes you can look through there, and it basically mentions those two pull-up resistors, these two little guys. So anyway, make sure and read through some application notes and things for different applications, different things that you're going to want to do with this. But for us, we're going to do something really simple. We've got 4 LEDs and a switch. Basically, we've got our pull-up resistor and our switch for pulling it to a low. So basically, we're using inverse logic. It's going to be 1 all the time, and then we'll be waiting to see the 0 from when you push the button. So what we're going to do is, as you depress the button, it's going to move an LED from the first one to the second one to the third one to the fourth one. So basically, you push the button, this LED will extinguish, the next one will come on. You push the button again, this one will extinguish, the next one will come on, and so on and so forth. And then it just loops back around. Once you get to the fourth LED, if you push the button again, this one extinguishes and this one will light back up. So basically it just a quick little trail that runs through here. You remember your 470 ohm resistors for current regulation coming into your LEDs. And that's basically all the hardware that we got going on here. So basically pretty simple. All we're going to do is push the button and the LED will move around. Now, where the EEPROM memory will come in is I'm going to basically save the location of it every time it moves, so that way if you remove power up here and then power it back up, it'll remember, it'll go to where the last position it was. So let's say if you had number 3 lit up and you pull the plug and plug it back in, 3 will come back on. It'll remember where it was because it'll be stored in this EEPROM basically. So that way you never lose your data even when power is removed. So that's basically the overview of what we're going to be doing. The next video we'll get into the coding of it to see how this is all programmed and tied all together.